Alright, welcome to Algebra 2, Mod 3, Unit 9, Lesson 6, Properties of Logarithms. So a little practice, I'd say pause the video, see if you remember everything from yesterday, but they tell you this is what log of 2 is approximately equal to. Figure each of these out. So I would call this log of 2 times 10. We know then that's the log of 2 plus the log of 10. The log of 10 is 1, plus 2 they just told you up here is 0.3010. So you should get a grand total of 1.3010. Do the same thing here. This is going to be 10 log of 2 times 10 to the negative 1, because you want one decimal spot to the left. So that's going to be a negative 1 plus the 0.3010. So you end up getting negative 0.6090. And this one here is 2 to the 4th. This is a little different offshoot. Remember, take the 4 and put it afterwards. So this is really 4 times the log of 2. So you got 4 times 0.3010. And you will end up with 1.2040. So that's a good start to today to build on our properties. We're going to save these for class. I want to talk more about them, so save for class here on these basic pieces. I mean, if you did log of 1, you know that's unwritten 10 raised to the 0 equals 1. So what can be equal to that? Okay, that's how you come up with it. That's where it's 0, so 10 raised to the x. But we're not talking about that right now. 10 to the 0, anything to 0 is 1, so 1 equals 1 and it works. But I want to talk more about these in class. There's actually applications we're going to do to it versus in the video here. So save these first 6. Once again, save for class. So leave that part blank. We will talk about that the next day. Alright, so we're going to manipulate some of this stuff. So this is half log of 25, which is 5 squared, plus the log of 4. And all they want us to do is rewrite as a single logarithm or number if possible, and sometimes you can't combine them. You can take this 2 and put it out in front, so 2 times a half, log of 5. Well, what's 2 times a half? They cancel. So I basically just got log 4, 5 plus log of 4. And if I take that a step further, and then you know the rules, when we multiply the two things, we actually turn out adding individually, so we can reverse that, and we actually multiply together. So 5 times 4. So my final answer, this thing turns out to be the same as log of 20. This one I would apply the same way, 1/3 log. Well, how can I rewrite the 8? Well, 2 to the 3rd power. And this one is log of 16 here. Which is log of 2 to the 4th power. Take the 3, put it out in front. So 3 times the 3rd, they're going to cancel, right? And you're going to get just log 2 here. And you put the 4 out in front here, plus 4 log 2 here. So I basically got 1 log of 2 plus 4 logs of 2 equals 5 logs of 2, don't they? And how do I rewrite that? Well, I can go ahead and put that back 5 up as the exponent in reverse order. So that's log of 2 to the 5th. And what's 2 to the 5th? 32. So that thing turns out to be the same thing as log of 32. Got to manipulate whatever way you can. Lots of ways of doing, going forwards and backwards with all the rules. 3 log 5 next. A little stranger. So this is log 5 to the 3rd power, so bring that 3 the other way up top as an exponent. And believe it or not, I'm not even going to touch the log of 0.8. Yes, I could say it's 2 to the negative 3rd in a sense. But if I go to this way and I'm dealing with this, this is log of 125 plus log of 0.8. Doesn't matter what way you get it, there's a lot of ways of getting there. And then if I multiply 125 times 8, you get log 100. So straight out that way. But it could be done other ways. Keep that in mind. A lot of ways of doing these. In these examples here now, we can bust this up. We can say, hey, this is log of 3 plus log of x squared plus log of y to the 5th, which turns out to be equal to log of 3 plus 2 logs of x plus 5 logs of y. Nothing wrong with that answer. And they said rewrite it with terms of x, logs of x's and y's. Next one. Now remember the square root, so can't this really be the log of, what I'm doing here is x raised to the 7 halves, because you're taking the square root, times y to the 3 halves, if I change that into fractions. So then I've got log of x to the 7 halves plus log of y to the 3 halves, and then just rewrite it. 7 halves log x, like they want, plus 3 halves log y. And that's in terms of logs x and log of y. Alright, so now we're going to play with even more log rules here. This is going to be log 10 to the 10x equals, take log of this side, 100, but 100 is 10 squared. Well, I now have them both log base 10, so all I have to do is do what we did earlier in the unit, set the exponents equal. So 10x equals 2, divide by 10, and my answer turns out in this one to be 1/5. Take a look at the next one. Take log of this side, which is 10 to the x minus 1, equals log of the other one here, which will be 10 to the, and then we've got to put a negative 1 times the x plus 1, because you are flipping it. So now all you have to do is both log of 10, so you can set the exponents in there. So I basically get x minus 1 equals, and then I would distribute the negative sign on both. So a negative x and a minus 1. I'll turn around and add x to both sides, and I'll turn around and add 1 to the other side. And what happens? That cancels like we're supposed to. You get 2x equals 0. So x, when you divide by 2, is going to be 0 as your answer. And then this one here, log of this. I got 100. Well, remember, 100 is 10 squared. So I got 10 squared raised to the 2x, right? Equals log of 10 to the 3x minus 1. Well, remember when I raise powers to powers, that thing is the same thing as 4x. So I would set up 4x, because you multiply, equals 3x minus 1. Move the 3x over, and I get x equals a negative 1. So all we're doing is manipulating and figuring out what the x's are. You're actually able to solve with logarithms that way. Number 10, we continue solving. So this is log of 10 to the x equals log of 2 to the 7. So log 10 to the x equals 7 times log of 2. So we end up setting x equal to 7 log of 2 and just leaving it that way and not figuring out what else it's equal to. Just in terms of 7 log 2, which you could punch in the calculator. The next one, you've got 10 to that, so you've got basically log of 10 raised to the x squared plus 1 equals log of 15. So x squared plus 1 equals log of 15. What I will do is bring the 1 to the other side, minus 1. So now if you come up here, you've got x squared equals log of 15 minus 1. And then how do I undo squaring? I take the square root of both sides. Don't forget the plus or minus. So x equals plus or minus the square root of log 15 minus 1. Yuck. That is what it is. Can happen that way. In C, I can rewrite this as x times log of 4 equals 3 times log of 5. And they're solving for x, all I got to do is divide by log of 4, divide by log of 4, and there's your answer. They're going to cancel. That's what the thing turns out to be. So, going back to the 6 rules that we kind of skipped, here's a summary of them if you want to put them in there. But log of 1 is equal to 0. Log of 10 is equal to 1. Log of 10 raised to the r is going to be equal to just the r part. Okay. Log of 10 raised to the log of x is just going to be the x. If you got the log of x times y, it's the same thing as log of x plus y. And if you got this, log of x raised to r power, you put the r out in front and multiply it. Those are the basic ones. There's a couple other properties we haven't done yet, but if you got 1 over x, you can put a negative sign in front and take that negative out of the equation right away. And if you're dividing these two, it's just like you would think, log of x minus the log of y, like we do with the exponents, since these are exponents and that's where logs come from. So this is a good page to start with all your rules that you kind of need to know for logs, and then take it in further. All right, we'll see you in class.